All right, this is Module 2, Lesson 2. We're going to continue what we did in Lesson 1 with the whole idea of counting up and counting down. This diagram right here kind of shows us what we did in Lesson 1. If we were starting at 0, counting up 2, you can count up with 2 arrows. Remember, we switched it to being just a straight arrow after a while. From there, we added 4 positive. We go up 4 more. We end at 6, which is where our answer is. That's counting up. Then we talked about counting down. If we start at 0, count up 2 because it's positive, and then count down 4 because it's negative, we end up at -2, which was our answer. So that's what we covered in Lesson 1. We're going to continue with this idea, adding numbers using number lines and the counting up, counting down method. All right, so let's start with the first one. Complete the steps to find the sum of -2 plus 3. We're going to fill in the blank as we go to find out what -2 plus 3 is. So it says place the tail of the arrow on 0. We're always starting at 0. And then we're going to draw the arrow 2 units to the left of 0. The reason we're doing that is because it's negative, so we're going to the left. We're going to stop at -2. The direction of the arrow is to the left since you are counting down. From there, we're not starting at 0 anymore. We're going to start at -2. We're going to draw the second arrow 3 units to the right since you are counting up from -3. So this is 3. Oops, that's actually 4. Let's make that 3. And we're going to stop at 1. Now, circle the number where you stopped. That's 1. That indicates the ending value. Now, we're going to write a number sentence for this. A number sentence is going to be -2 plus 3 equals 1. So it's telling us the addition problem and the answer, and notice that it's horizontal. A number sentence is always horizontal, not vertical. So the answer is 1. Now let's repeat the same process, but for 3 plus -2. So we're going to start at 0. We're going to count up 3 since it's positive. From there, we're going to count down 2, which puts us at 1. So let's write the number sentence. 3 plus -2 equals 1. What can you say about the sum of -2 plus 3 and 3 plus -2? What did we get when we added both of those? Did you notice that the answers were both 1? So it doesn't matter if you start with -2 and then add 3, or if you start with 3 and add -2. The order does not matter when you're adding numbers. And we call that the commutative property. So they have the same sums. Order does not matter. When adding. Because of the commutative property. All right, so let's do it again. How does the absolute value determining the arrow length for -2? Well, if you're starting at 0 and you're going in the -2 direction, that's to the left, the arrow length is still 2 because when you're measuring, you're always in positive values. So the absolute value of -2 is still 2, and that's the same as the arrow length. So how does the absolute value determine the arrow length for 3? Well, once again, it's the distance from 0. So the absolute value of 3 is also 3. Notice that it's just distance, which is positive. All right, so without a number line, how would the absolute value help you to represent -10? Well, the absolute value of -10 is 10 because the arrow will be 10 units long. All right, so let's try this again. All right, so we're going to do this on your own. So please pause the video when you're done trying just these two examples. You can restart it and see if you are correct. All right, so we're starting at 0. It's -6 going in the negative direction to 6. And then from there, we're going to go up 4, +4. So we end at -2. All right, we are starting at 0, go up to 3. From there, you're going down 8. And you end at -5. All right, let's try this again. Find the sum of the integers represented in the diagram below. So what equation are we going to use to express the sum? Well, the first number was 5, +5. Then from there, it went back -2. From there, we went up 3. Now remember, we're adding every time we keep going. And our endpoint was 6. So there's our equation. So what 3 cards are represented in this model? So in this model right here, we have the 3 cards are 5, -2, and 3. And you can get that right from the arrows above. So in what ways does this model differ from the ones we used in lesson 1? If you're looking at those arrows, we started off using the arrows like counting every single one. I call those little loops. And this time we've kind of gotten away from that, just using the straight arrows. So the only way it's different is because of those arrows. So let me write that down. So instead of loops, we use straight arrows. So can you make a connection between the sum of 6 and where the third arrow ends on the number line? Well, the sum of 6 is where the third arrow ends, because that would be the sum. So would the sum change if we changed the order of the numbers? So if I did -2, then 3, then 5, would that change? And we just talked about the commutative property and how that order does not matter. So no, sum would not change. Would the diagram change? Now this case would be yes, because you're starting with -2 first, then going to 3, then going to 5. So the diagram would change, but the sum would not. All right, so let's apply this to our real world. Suppose we receive $10 from your grandmother on your birthday. You spend $4. So let's write an equation that represents this situation, also called the number sentence. If you are receiving 10, that's a +10. Then you spend 4, which would be -4. And that would equal what? Okay, well, let's go to our number line. Start at 0, go up 10. From there, you're going to go down 4. And your sum would be 6. And that is all we have for this lesson. Your problem set is on the page following.